Hello and welcome to today's webinar, Combating Rogue URL Tricks, how you can quickly identify and investigate the latest phishing attacks. This event is brought to you by our friends at KnowBe4. Thanks so much for joining the webinar. We've got an amazing presentation lined up for you today. Before we get started, there's just a few things that you should know about the event. My name is David Davis, and I'm glad to be the host for today's webinar. We want this event to be educational. I mean, security is such a hot topic these days. We encourage your questions there in the questions pane of the audience console. I see many of you have already said hello and good afternoon. We appreciate that, but we also want your technical questions. We even have a best question prize, which I'll talk about here more in just a moment. We'll be taking your questions live at the end of the webinar today. We also have a number of resources there in the handouts tab. We've got the free phishing security test link, as well as the red flags of rogue URLs PDF that you can download. I encourage you to check out those resources now before the event wraps up, because they won't be as readily available as they are right now. At the end of the webinar, I'll be announcing the winner of our Amazon $300 gift card door prize. If you're watching this event on demand, of course, that drawing has already occurred. The prize terms can be found right there in the handouts tab. And then, as I mentioned, we also have our best question prize for an additional Amazon $50 gift card. That just shows how much we encourage your questions. We want to help to solve your security challenges. And without further delay, I'm excited now to introduce today's expert presenter. You know him, you've seen his presentations. They're always amazing. Roger Grimes, data-driven defense evangelist at KnowBe4. Roger, it's great to have you back on. Take it away.
Thanks. I'm always glad to be here. Thanks, David. Thanks, everybody, for showing on up. I'm going to be talking about combating rogue URLs, uniform resource locator links. And really, one of the best things anybody can do to fight social engineering, hackers, malware, that sort of stuff, is to recognize what is or isn't a rogue URL. If you haven't met me before, I talk a ton. I am a fire hose of information. I have 92 slides today. If I'm going to try to leave 5 minutes for questions and answers at the end, there's no way you're going to get through all those slides. So you can download this slide deck and look at it like a book at the end. But I'm just going to try to give you a lot of really good, useful information. I've been doing computer security 34 years. I've written 13 books. Here's some of those books, and over now 1,200 magazine articles. And you know, a whole lot of it has been about how to recognize rogue URLs and trying to fight hackers and malware. I work for KnowBe4. We're the world's largest integrated security awareness training and simulated phishing platform vendor, which means we try to help people not to get phished. And again, a big part of that, this really is a natural fit, this talk, is how to help people understand what is or isn't a good URL. And that's what I'm going to show you today. I'm going to talk about what a good URL looks like, and then probably give you at least 50 examples of bad URLs and tricks, really common tricks, and some uncommon tricks that the bad guys use to try to fool you. But we're going to start by understanding what a URL looks like. Everybody thinks they know what URL should look like. We're going to see and test your understanding. There's a really typical URL, right? www.knowbe4.com type thing. That's a very standard looking URL. The first part of that, the HTTPS part, that can be these days HTTPS or HTTP. Again, that's called the protocol moniker. That really can be a whole bunch of different things. We'll talk more about that in a minute. After the two forward slashes, you may have a host name there, and we'll talk more about that, followed by the DNS domain. That part right there, that's the part that's really critical to understand and get right. And the part after that, after the first forward slash, is what's called the resource path or object name. That's the thing your browser is actually downloading. The URL protocol moniker, again, most people think that it can only be HTTP or HTTPS, but really there can be a whole lot of things there. And depending on your browser and your operating system and how it's configured, depending on what you type in as the protocol moniker, it may actually even switch programs. Like if you type in FTP:// in Windows, if you have the file transfer protocol client installed, it will switch to that. If you type in file:// it will go into a net bias networking protocol. If you type in, if by chance you have Telnet 3270 for connecting to mainframes on your system, if you type that in the browser, it will start that program. So really, these URL protocol monikers, we're used to seeing just HTTP or HTTPS, but really it can be a whole lot of different things. Whatever the browser and operating system is configured to do. Actually, on Windows systems, if you go under the registry key called HKey classes root, there are literally hundreds of protocol monikers in there. And any program, any new program can install and make a new protocol moniker, which brings up itself. Like a lot of people don't know, as an example, in a Windows system, in a Microsoft browser, and it may work in non-Microsoft browsers as well, but you can type in ms-paint. So you could actually type in ms-paint // and it will actually start the Microsoft Paint program because it is a protocol moniker that's registered in the registry. After the protocol moniker, you're always going to have a colon and then // and then what follows that, typically, if it's there, is what's called the host name. Back in the day, what was really there was the host name of the web server you were connecting to, which could really be any host name. But a lot of times early on in the World Wide Web, it was www. These days, it is a lot of the worldwide, it's usually a virtual name. It's not the real host name. It's just this virtualized host name. And many times they still do say www, or it may be blank, or even if you leave it blank, it may kind of in the background default to www, but it can be other things. I've seen www3, w3, web, whatever they want to call it. So again, after those two // you may see what's called the host name, and it may be real or virtual. Followed by, after the period, you'll then get the DNS domain name. And that, again, is the most important part of understanding what is a real or a fake URL, is the DNS domain name. It will happen after the first period, after those two //. And it may just be the domain name, although it also could be like a subdomain under the main domain. So you could have like, example.example.com and example.example.com or subdomain under main domain.example.com. So you could have these subdomains, which you're really interested in, those, just that example.com. That's going to allow you that the last example.com before the first // that is really what you're looking for, because that's going to tell you whether or not you're really going to a particular domain that you think you're going to. And then usually you're going to have what's called this top level domain name, .com, .pub, .org, .biz, .mil. Back when the internet first started in the late 1980s, the only top level domain names you would see there is like .com, which is still the most popular, .org, pub, gov, that's for the U.S. government, .mil for the U.S. military, .biz, and so on. But these days, there's literally hundreds of top-level DNS domain names. I went too far there. And they can be anywhere from 2 to 4 to 6 to 8 digits these days. And they can be all sorts of stuff, although what's really common is these 2-digit country codes, like US is US, or United States is US, AU for Australia, CH for China, RU for Russia, and that sort of stuff. Let's see, PL for Poland, I think it's for Poland, and so on and so on. There's different ones that you'll see there. The most common one's .com, but these days you'll see a lot of malicious websites that will have like .biz on them, or something, .coach, .codes, .construction, because they're allowed to have a lot of different top level domain names today, and they'll use those top level domain names to trick you. Like it may say, Microsoft.biz. Well, Microsoft.biz, as far as I know, is not owned by Microsoft. Maybe it is, but there could be something like, Microsoft.com.biz, and that would not be the same as Microsoft.com. After the last / anything you see there is what's called a resource name. So that's the object or the page that's being downloaded by the browser. It may be missing. If it's missing, most browsers will try default to what's called index.htm or index.html. But usually what will be there is an actual web page name that gets downloaded, or an object within that web page or location that gets downloaded. So that's what a basic URL looks like. Again, so you'll have that, protocol moniker at the very beginning, followed by colon / followed by the host name, followed by the DNS domain name and top level domain name, followed by / and what could be one or more subpaths. And finally, you get to the resource name of the web page or the object that's being downloaded. Although a lot of people don't know this, you can actually put in different port numbers. By default, you have 65,535 different TCP ports and 65,535 UDP ports in the TCP/IP protocol. By default, when you type in HTTP, it goes across port 80. When you put in HTTPS, it goes across port 443. But you can actually put a colon in after the top level domain name. You can say colon and put in a different port that forces the browser to connect over a different port number. So you could actually, say HTTP, but force it saying colon 443 to go over 443, even though it really was only HTTP and not HTTPS. A lot of times back in the olden times, back in, before the last couple of years, there used to websites and stuff would send people across all kinds of browser ports or all kinds of ports. These days, everybody just takes the default, which is port 80 or 443, but just know you could be forced somewhere else. If you ever see a question mark in a URL, that starts what's called the variables, and you can have one or more variables. So again, if you see a URL and it has a question mark, anything after that is going to be a variable, and it can really be anything with an equal sign and then the value of that variable. Website, whenever you see that, the website that you're on is using those variables to track you, to see where you came from, what current page you're on, what ad brought you to the website, and so on. If you have multiple variables, they'll be separated by ampersands. Like here's an example of a URL, a real world URL that was secureworldexpo.com, industry news. Then you'll see that question mark, then UTM_campaign. That means they're trying to track what marketing campaign brought me. And it's like, oh, what brought Roger to this particular web page apparently was industry news, which was some type of industry newsletter that was sent out, and so on and so on and so on. So again, anytime you see these question marks, they're variables with the different variables that the website is using to track you, including the value of the variable. And you as a user could actually change those variables. Sometimes I play around with those variables to see if it changes the website that I get. But the most important skill out of everything I show you today, again, is figuring out what is the true DNS domain that you're on, because the hackers are going to try a million different tricks to make you think that you're on a particular website when really you're somewhere else. And if you know really well of how to tell exactly what DNS domain name you're on, that allows you to figure out 99% of the time whether or not you should trust that URL. There's an important, the most important thing you can teach yourself and your friends and family and coworkers and loved one is how to know the difference between these three different URLs. And the first example there, the entire thing is the DNS domain, although really, if you're going to look at what's called the parent domain, it's just domain.com. So example.com is a subdomain under domain.com, but the DNS domain, parent domain for that first URL is just domain.com. And the second example, it's example.com. Example.com, because of the / that says example.com is the parent domain, and domain.com is really just a resource name. Could be the web host, could be the host name or a page name or something. But attackers many times try to trick people into thinking they're going to other websites because they look like they're domain names, but they're really being used as resource names. Or in the last example there, in the last example there, the parent domain really would be com.domain. So with the subdomain of example. So anyways, understanding the difference between these three types of URLs and where the real domain is, the real parent domain, is the best skill that you can pick up to teach yourself and loved ones of how to realize what the real domain name is. Now, a lot of browsers these days will highlight in bold what the domain name is and subdomain. Like in this case, it says secure.bankofamerica.com. Bank of America is a subdomain, or it could be a host name under that, but at least and again, it's highlighted in bold. is that you're on bankofamerica.com. So a lot of the browsers will do this. We'll try to highlight what the real domain name is, so that if a hacker or phisher or spammer is trying to fake you out with some other type of bogus name, you'll know what the real domain name is. And if I see in this case like bankofamerica.com or secure, if I know that it's bankofamerica.com, anything that comes before or after that really is likely coming from bankofamerica.com. And secure, again, is just a subdomain or a web page or a host name or something like that. And I can trust this particular link because it really is, whatever's in there really is coming from bankofamerica.com, and bankofamerica.com is not trying to hurt me. Although, look at this last example. It was a malicious URL sent to me in a phishing link a long time ago, but they were trying to make people think that they were going to microsoftonline.com. It was pretending to be, I'll show you the email later on, but it was looking like an email, and it was trying to force me to think that I was getting this email phishing. It was a phishing attempt, but appearing to look like it came from Microsoft. So they actually registered this web page at devopsnw.com, just some bogus domain that they created, put a website up on there. But login.microsoftonline.com is not the domain name. That is just the resource path name that's under devopsnw.com. And of course, the browser is highlighting that to show you that that is the real parent domain name, not logon.microsoftonline.com. So I'm going to show you some more examples of these types of tricks. The most common things are these look-alike, sound-alike domain names. We actually run, you can download this free tool called Domain Doppelganger. You can download that from our website, Domain Doppelganger, but it will go on the internet. You put in your domain name and it will bring down all the other registered domains that are close to your domain, many of which could be malicious. And you can see, like, so the original domain name we searched for in this case was our own domain, knowbefore.com. But you can see, like, on the second example there, somebody had registered something that said knowsbefore.com or hyphenation know-b4.com. All of these other domain names are not our official domain name. It is likely most of these were registered by malicious people trying to do phishing attacks in our name. And what's lucky, you can actually, if you find out that someone's using a look-alike, sound-alike domain name that's close to your domain name, you can actually file and take over that domain name, if you can prove that it was being used maliciously. So a lot of companies will proactively search out these different domain names and buy them up or take control of them if they've been used malicious. So you should run Domain Doppelganger on your company's domain just to see how many other sound-alike, look-alike domains are out there. And again, many of which, they could be innocent things, but it also could be being used maliciously to phish other people. Here's another lookalike domain. So this was a real URL that came my way in a phishing attack. It was the email was claimed it was from PayPal, but it really wasn't from PayPal.com. It was really from com.bank. So someone opened up a subdomain under the new top-level domain bank, and then they opened up a subdomain called PayPal.com. But that is not PayPal.com. That's paypal.com.bank, the bank being the top level domain, not paypal.com. Or here's another one. It was claiming to be that it was from Microsoft, like Microsoft.com, but really the domain name is really quite long. The parent domain is really login-update-December20info. That really is the whole domain name, but they're hoping that someone would just see the words Microsoft.co or Microsoft, think it was Microsoft.com, and login update. This is a domain that is not from Microsoft. Here's one that's claiming to be from Bank of America. Well, if it was really from Bank of America, it'd say bankofamerica.com. But if you look at the URL at the top of the page there, if you can read it, it says bankofamerica.doc.com. So the real domain of this is doc.com, and they got a subdomain of Bank of America. And doc.com, I guess, didn't catch that was, some fake maliciously used website. So again, the parent domain of this particular link is doc.com, not bankofamerica.doc.com. But a lot of people might miss that. Or here's another Bank of America one that says Bank of America activation. Well, that's got no.com on there at all. But a lot of people are like, oh, it's Bank of America activation. No, it's not. It's not, I don't know what it is, but it's not bankofamerica.com/activation, which is the type of thing it really would be. Or here's another one. It was claiming to be PayPal, but it was security-paypal-centers.com. So that means that the parent domain is really security-paypal-centers.com. It's not paypal.com. Or here's another one, if you can read that was saying Google Chrome updates.com. This is from a phishing attack I got that was claiming to be from Google, and it was like, run this to patch your Google Chrome browser. There's a new security patch out. Well, the URL again was googlechrome-updates.com. I was like, I wonder if this is really owned by Google. I knew it was a phishing attack because you don't have to run anything to update your Google Chrome browser. It's a service that automatically updates itself. But I went and looked up the domain to see who owned I did a DNS lookup on googlechrome-updates.com, and it was not owned by Google. It was owned by some weird company or something like that, spammers, phishers. So again, and you can see the host name was www17, not www. But googlechrome-updates.com is not the same as google.com or something like that. Here's another one trying to claim to be PayPal, but it was x-paypal.com. So a lot of people think, oh, it's paypal.com. Nope, they put that x-paypal.com. So this, the spammers or phishers were able to register x-paypal.com and use it for a little while till PayPal found out about it and took it away from them. Here's another good example. This is a common phishing attack that we see on social media accounts. Someone will go, oh, my mother was hit by a car and, you need to go here and look it up. Or my cousin got shot. Go look at this video and we need your help to find out who this is. And they tell you that they're going to take you to a CNN video or something. But if you look on there, it's CNN News Alert 1T or 1T133 wixsite.com. So the parent domain of this is not CNN.com. It's Wixsite, which is went past it again. Wixsite is just a public web hosting service where you can buy and put up your own website, and they give away free websites for a while. So this is a really common thing where they're like, oh, it's a CNN video. It's not. It's just some fake video they created looking kind of like CNN News Alert, but really it was just hosted at this free website. Here's a phishing email that came in where it was pretending to be from us, KnowBe4, trying to do a training reminder to one of our customers. But if you look at that URL, it was training-knowbe.e4.com. So the parent domain is e4.com, and they made a host name of knowbe. I got to tell you that my hats are off to them with that little trick there, right? They made a domain name of knowbe.e4.com. That is not the same as knowbe4.com. Let's see another example. This is a spam email trying to claim that it was coming from Microsoft, but they actually came from Outlook One, or it wasn't Outlook.com, which would be the free email service. It was really OutOneOok.com, a lookalike domain. So they registered a domain called OutOneOok.com and then made it kind of look like it was Outlook.com, which is Microsoft's free email service. So again, not Outlook.com. Or here's some other examples, like one's claiming to be from Bank of America, but really it wasn't from Bank of America. It was from customerloyalty.accounts.com and actually came from a domain called shakeaway.com. Something from Bank of America is going to say bankofamerica.com. Or this Office 365, it was claiming to be from Microsoft, but really it came from soft.com or snspreview7.com.au, which would be Australia. In any case, anything coming from Microsoft is going to say Microsoft.com. Or the bottom one there is, again, another spam email trying to claim like it's from Microsoft. But what I love about this one is two things. One is it actually comes from the email name is Microsoft Online, but they misspelled online. They forgot to include the third O. There's two O's in Microsoft. There should be a lowercase o in online. I don't think Microsoft's misspelling the word online. But on top of that, on Microsoft.com means it comes from Microsoft, one of Microsoft's free email services, Hotmail or Outlook.com. Microsoft, if I got an email from Microsoft, it's coming from Microsoft.com, not from their free email service. And when you get emails and things like that, it's really common to get these what's called domain mismatches. So again, this is claiming to be from Microsoft. In this case, they're telling me that I was running out of space or something like that. But if I hovered over the URL there, again, it was DevOps.nw.com. That was the domain name, even though they were trying to say they were from Microsoft. Or here's another one, an email one of my customers, one of KnowBefore's customers got that was claiming to be, this is a fake COVID email claiming to be from the U.S. Department of Health and Human Services. But if you look, the email's got all kinds of other domains, one coming from gmx.com. When you hovered over the link in the email, it was coming from someplace like in France or something like that. In any case, these two domains were not from the U.S. Department of Health and Human Services, which would probably end in a .gov, I'm guessing. Here's another one where it's looking like it's a phishing email, but it's looking like it came from LinkedIn. But really it was, if you hovered over the button, it was LLLinkedIn.com. This is actually Kevin Mitnick, our chief hacking officer, actually registered this URL, but we've seen some others coming from Nigeria that said LLLinkedIn.ni for Nigeria. So again, if it's not LinkedIn.com, it's not LinkedIn.com. Here's another example. I got a phishing email claiming to be some shipping documents, and I had to pay for a shipping invoice, and supposedly it was from Maersk. Maersk is the world's largest shipping and container company. I don't know if I'm saying that right, Maersk, but they're the world's largest shipping and container company. If I got an email from them, it really would say from Maersk.com. It wouldn't be from onlinealex.com.pl in Poland or something like that. Or it's also telling me that it's coming from this email account on Microsoft.com, which again tells me that it's one of these free email Microsoft accounts that someone's created, like a Hotmail account or something like that. If you get an email from a major company that says it comes from Hotmail or Gmail or, on MicrosoftOnline.com, it's not really the large company Maersk or Microsoft or, PayPal or whatever, KnowBefore. They're going to come from their own domain name, not some free email service. Also seen where hackers many times will convert longer URLs into what's called short URLs. Short URL shorteners are all the rage because of Twitter. It used to be that Twitter only allowed you to use 140 characters, and sometimes your URL would take up the whole 140 characters. So Twitter made a URL shortener, which would replace your long URL with a shorter URL. And hackers now use that a whole lot. Turns out a lot of URL shorteners used by phishers, over 50% of the time, they're using the URL shortener beginning with t.co from Twitter. They also use Google's goo.gl, and so on. So anytime you get a short URL, make sure you expand the URL before you go to it. You don't want to just blindly click on every shortened URL. I like, you can go to any URL exploder service. I like going to expandural.net. Like here's an example where I got this message from purportedly from Google, but I wasn't sure if it really was from Google, and it has one of those short URL links. So I put that in the expand URL, and when I got through, it told me, oh, this really came from support.google.com. You can see that kind of in the middle of the screen, support.google.com. Okay. This really did come from Google. Well, I got another URL and another potentially phishing website, and it was a short URL from Google. I put it in, and this one pointed to malshare.com. Malshare.com it hosts a whole bunch of malware. Malshare.com. Don't go there unless you want to intentionally download a whole lot of viruses and things like that. Oops, I went past it. But if I would have clicked on that shortened URL, it would have automatically downloaded malware or tried to download malware onto my desktop. So always expand URLs before you go to them. Know that URLs can also be represented by many other things. We're used to typing in, knowbefore.com, google.com, microsoft.com, paypal.com, but they can be represented by their IP addresses instead, or other special characters. Like if you look at this URL here, it's http /192, 217.2.192. That's Google's, one of Google's IP addresses. But they also can be represented by special characters. In this particular case, it's known as percent encoding. There's ASCII characters, usually 0 through 255. And different characters represent, or different numbers represent different characters. They're encoded in hexadecimal. But if you see like that %7, %77, that's a lowercase w. So if you look at this percent encoding, the %77, %77, %77, that's www. And if you were to convert each of these characters, percent encoded characters, into the characters they represented, you would see that this URL really is knowbefore.com, www.knowbefore.com. Hackers like to encode the URLs. If they're going to send you to a bad place, they would rather encode it so you can't really figure out where you're going. So basically, if I see percent encoded URLs, I don't go to them unless I first convert them. A lot of times they like to do these overly long URLs, like they'll put in, like maybe they have some website, I call it evilwebsite.com, but really some other website here, but they'll put a lot of characters. And what it is if you're a person like me that likes to look at URLs to see where they're going, if they make it have hundreds and hundreds of characters, it kind of runs off your screen and it makes it hard to figure out where it's really going. What I would say to people, if you get an overly long URL, chicken out. Don't go there if you can't verify where that URL is really going. And in this case, it was actually going to evilwebsite.com, but then they tried to make it look like it was going to irsgov.com or irs.gov. It really was evilwebsite.com was really where it was going to take you to. Now I'm going to go through some advanced URL phishing techniques. This first one is a pretty advanced technique called cross-site scripting. When you type in a URL or you click on a URL, it's supposed to really act like text where it's display only. Like it's not meant to be executed. But there are times when websites or applications have errors in them, and they allow that code to, instead of being display only, text only, it can actually be manipulated into being executable code or executable scripts that then get executed on your browser or your browser onto the web server that you're connecting to. And the way that, if you're a pen tester or a hacker, every time you go to a new website, you're always kind of checking to see if the website is vulnerable to cross-site scripting. And the way that any pen tester or hacker would check is post this type of thing to the web server. So you can actually create, I'll show you in a minute, a URL that has this in it. But basically you're saying script, JavaScript, alert, hello world. If you run this particular small JavaScript, if I was to type this into my browser, go to a website, type this into my browser, it's probably going to error out. The website's going to go, I don't know what you're talking about, or something. But if when I go to the website, instead of it erroring out, if it actually pops up a box saying, hello world, this site says hello world. As soon as an attacker or pen tester sees this on a website, it tells them that this website has an error. It's configured incorrectly, and it will allow cross-site scripting. As soon as I tell you, as a penetration tester, I'm sure hackers, when you know that a particular website's been misconfigured and allows cross-site scripting, you start getting pretty giddy. You do this test, and you're like, yep, it's vulnerable to cross-site scripting. And most websites are not, maybe 1 out of 100 or something like that. But when you find a website that is, this tells an attacker, I can create a link that will execute my code. And it will execute the code on whoever you send that link to. So then you could create a phishing email, send it to someone. If they click on it, it takes them to the website that has the cross-site scripting vulnerability in it, and then executes that code. So again, what you're trying to do, instead of putting hello world in there, you're putting in what's called a malicious JavaScript or a malicious JavaScript redirector, which would then take the user to another web page. So again, the cross-site scripting is an attack method where the HTML code that was meant to be display only instead gets executed on a web server, and it can that web server, that code can be executed on the server from your browser to the server, or actually in your browser session. It can end up executing script or code on the client that has the link. So instead of being display only, it becomes something executable. What can they do? Well, sometimes they can get data or your session cookie and take over your session. Sometimes it can execute code on you. And then sometimes it actually can use your permissions to then run commands or code on the involved server. So the attacker can send you a link that executes code on the server that you're visiting, but in your context, in your browser's context. And let me say, here's a really good real world example of how cross-site scripting can work. I was working for Foundstone in a penetration testing team, and we were trying to break into the world's largest cable box or cable company. They had a new cable box they were getting ready to deliver to the rest of the world. And they wanted us to see whether we could hack it or break into it. So it was just a cable box, but it was one of the first online, internet accessible cable boxes. And it also had a firewall on it. And what we found out is that anytime you attacked this cable box, so we were attacking this cable box trying to break into it, but we found out that cable box, its firewall log file was vulnerable to cross-site scripting. And we got very excited as soon as we learned that, because it meant that we could use this to run our executable code on other people. So we actually attacked the cable modem with a cross-site scripting attack that we knew about. And then so we attacked the cable box with it, which meant that cross-site scripting attack ended up in the cable modem's firewall log file. And anybody opening up the firewall log file would have that cross-site scripting attack executed in their browser. So we quote unquote attacked the cable box with this cross-site scripting attack that we knew what it was going to do. That would, would end up putting our cross-site scripting attack in the firewall log. And then we called the cable box tech support and told them, hey, we acted like we were just regular customers. Hey, our cable mode has been really slow, and I think that we're being attacked. Can you check our firewall log files to see if we're getting attacked? And the guy said, yeah, I can take a look. You are getting attacked. I can see you're being attacked. And what he didn't know is all of a sudden his password files, our cross-site scripting attack, tried to download his password files. We just assumed they were running Linux or Unix or something like that. And we had the cross-site scripting attack send us his pass, WD, and shadow files. And lo and behold, when the guy went, oh yeah, I see these attacks, all of a sudden his password files showed up on our screens. And we were able to then use those passwords to take over the entire corporation. We went from one single cross-site scripting attack on a cable box to taking over the entire company in 30 minutes. That's kind of the power of cross-site scripting. So again, the way that it works is that you have to have a website or service that has this cross-site scripting bug. They're not supposed to have it, but many of them do. And then again, you can, as an attacker, when you have this ability, you can execute code on somebody's browser, or you can maliciously redirect them to another website. So they thought they were visiting, Microsoft or Noble4 or PayPal or something like that, but really they get maliciously redirected to another website or something. Maybe even code gets downloaded to their screen. So again, the attacker methodology is they have to find a website or application or service that's vulnerable to cross-site scripting. Again, they usually do that by doing that testing by going hello world and seeing if the alert script works and says hello world. Then they'll decide what they will want to do once they've identified a cross-site scripting attack. Then they'll create a malicious URL that has that cross-site scripting attack in it and what's called the payload. Send it to the victim. When the victim sends them the link, it executes on their browser session and or on the server that they're visiting. So a really good example is here, where it goes to example.com. But anytime I see a URL that has script in it, that word is usually, I don't think it can be encoded. So you'll always see script in there. As soon as I see script or maybe on load, as soon as I see that, I'm watching out, because most URLs should not have scripts in them. They should just have text-based URLs. So look out for any URL that has script in it or on load. On load is when you load the window, do this, especially if you can see that link.href, HTML ref, that means it's going to redirect you somewhere. So if I see a URL that has script in it, on load in it, or link href in it, I watch out, because that could be a cross-site scripting attack, or it could be redirecting me. Of course, the bad guys try to encode that, do that percent encoding. So a lot of times you're like, oh, I can't see what it's doing. But if you look even in this percent encoded example, you'll see the script and / script. So you'll see href, you'll see script and / script. And that's because those elements, those HTML control commands, can't be encoded. So even if they try to encode the whole command, if I see on load a.href or script or / script, I'm worried about some type of advanced phishing attack, and I'm not clicking on that URL. Also, if you see something like here, if you ever get an email that acts like it has a file attachment, but you hover over it and it's not really a file attachment, it's a link to a file attachment, it's almost always bogus. Never seen an email that had a fake file attachment that wasn't bogus. Some people ask me, well, what do you think about digital certificates? If the website has, people say if the website has a digital certificate, so it has HTTPS on it, doesn't that mean that it's safe? Like, there's an example of a bankofamerica.com digital certificate. And the answer to that is no. Rogue websites are able to get digital certificates, no problem. A digital certificate does not mean the site isn't malicious. It doesn't mean that you can trust the site. Most phishing websites have valid, trusted certificates, and that's mostly because of a certification authority website called Let's Encrypt that allows anybody to create a certificate for any domain that they own, whether it's malicious or not. So now, if you look at that, even by the time 2019 came around, almost 80% of all phishing websites had a digital certificate. So again, if you see a digital certificate, that doesn't mean that the website isn't malicious. Although if you see a digital certificate and it's valid and it says like bankofamerica.com, well, then it's really from bankofamerica.com. But typically these malicious websites are not bankofamerica.com. It's some type of gobbledygook. But they do have valid digital certificate. When you get a valid digital certificate, you can trust the path that is in that digital certificate as being the right path, but it just doesn't mean that you can trust that particular website. And another example, again, a lot of times they're going to try to obscure the URL so that you cannot read it. All operating systems, applications, devices, and services use what's called a character set to define what characters and languages can be used to display and print characters. The first computers that came out used ASCII, what's called the American Standard Code of Information Interchange. It was only 128 different characters. But remember when we were saying like the %77, the %77, if you look all the way down in the last column there at the 770X77, that means offset 77 are, but you'll see that as a little W. So that percent encoding that I showed you before, like where it went www, where it was doing %77, %77, %77, the codes or the characters that were being encoded came from the ASCII code set. Almost every computer in the world supports ASCII. But they actually, so ASCII with 128 characters there, it had like the alphabet, the uppercase, the lowercase alphabet, numbers, some symbols, some control characters, but it really wasn't a lot. So by the 1990s, we had actually by late 1980s, most computers were using something called ANSI, American National Standards Institute character set, and that could support 218 different characters. But even then, it couldn't, 218 characters, not enough to handle the world's languages like Cyrillic, Russian, Chinese. So starting with Microsoft 2000, Microsoft started to use something called Unicode. And Unicode has hundreds of thousands of different characters. It supports every language, active and ancient, which I think is pretty wild. Active and ancient. So Unicode supports Egyptian hieroglyphics, as an example. But Unicode can represent millions of different characters. Now, when it's applied on the World Wide Web, they took Unicode and they said, it's going to be a smaller set of Unicode. We're only going to support 1 million characters. So on the web, there's a Unicode character set, but it's a smaller number of characters, and we call it UTF-8. Unicode Transformation Format 8-bit. Sometimes you hear it called Punicode or Punycode, but essentially every time you type in a URL or see a URL that's in a browser, it really is using this UTF-8 character set. So like you think you're typing in a W, but it's really being converted to that code, %77 or whatever. So that the problem is that with over 1 million characters that Unicode can represent in UTF-8, some of the characters look like each other. And phishers will use that, like you think you're typing in, or maybe you're seeing a URL that has, an A in it, and you're like, oh, you think it's like your Unicode Latin A. That's the English A, but it really could be the Russian A, Cyrillic A. And so the URL that you click may look like it has a regular A in it, but it really is a completely different foreign language. So there's many different characters that look the same when you type them in or when you click on them, but they're really completely different languages in the background using the UTF-8. And it allows phishers to create new domain names that look like other domain names, but really are completely different behind the scenes. They're called homographic attacks or homography attacks. Like you can go to this link here where it looked like you were going to Apple. Like click here to go to apple.com, but really those letters, the A, the P, the L, the E, were really different foreign language characters that if you clicked on them, actually took you completely somewhere else to this Chinese website. And they gave another example of, hey, epic.com, looks like Epic. But when you clicked on it, it really was Russian Cyrillic letters that took you somewhere completely different. In this case, again, to a Chinese website. And just know that sometimes there's proof. You can go to proof of concept websites that if you hover over them may look one way, but if you edit, and when you put them in the browser may look one way, but if you copy, edit, paste it, it will look another. So there's little tricks they can play. So, the thing is, watch out for the domain name and where you ultimately end up going. Even today, most browsers will warn you if they detect a homographic attack. Like they're like, hey, Apple, if someone tries to send you to a fake Apple domain using Cyrillic letters or something like that, most browsers will warn you and say, are you sure you want to go there? Because it looks like the site you just tried to visit looks fake. Attackers will sometimes mimic sites by making small, hard to see changes in the URL. Do you really want to go there? So they'll warn you. There's a lot of redirection attacks out there. Like in this case, this is a URL that really will take you to adobe.com. Remember, I told you the most important thing you can recognize is what domain you're going to. And in this case, you would be going to adobe.com. But when this particular vulnerability was found, Adobe allowed anybody that used the variable P1, if you said P1 equals, you could then actually redirect people somewhere else. So an attacker could send you a phishing email that looked like it was from Adobe. And truly, when you clicked on it, it would take you to adobe.com, but then the ampersand P1 variable could then take you to any other website. So kind of like the cross-site scripting, when attackers found out that adobe.com had this error in it, that would allow people to be redirected somewhere else. They started creating a bunch of Adobe emails that would, again, in the first second, it would take you adobe.com, but then it would immediately jump you, in this case, to knowbefore.com. So watch out for these malicious redirection attacks. Another example, Google in Russia, and this is the real Google Russia website. Again, for a while, Google at Russia had this vulnerability, and the attackers found out that if they use this variable that was called BTNL and Q, ampersand Q, anything after that would be this malicious redirected website. So somebody could send you an email claiming to be from Google Russia, and if you went to it, you would go to Google Russia, but then immediately be redirected to this new website, which they percent encoded, so it was harder to tell. Or here's an example, real world phishing attack. I've got a link there you can go to. Daniel Gallagher talked about this one, but he got a phishing attack that looked like it was going to take you to ups.com. So the email said, hey, you missed your delivery, click here to, download your invoice or something like that. And when he clicked there, it did take him to ups.com. And so here's the URL he clicked on, ups.com. But if you look in there, it actually ended up being a malicious redirect in there that then took you, if you see that on error, that's kind of at the end of the second line, on error. What this said is, if you went to our website, ups.com, and there was an error, it allowed them to redirect you somewhere else. And that was meant that it would redirect you somewhere else on the ups.com website. But attackers found out that they could change that on error function to be almost anything and take you into any other website. So he was getting this phishing attack that looked like it was coming from ups.com. But when you click it, it really took you somewhere else. And that the way that you fight these attacks is realize that initially you're going to the real website, but if all of a sudden it changes and you're on some completely different website, you have to start to evaluate that URL all over again. Again, it was because this particular website, ups.com at the time, allowed this on error functionality that would allow you to get redirected to other websites. So when he clicked on this link, it would take him to ups.com and then dropped him off at a website called media-amazon.workers.dev, which, let me tell you, is not ups.com. So that's a good one to go read and talk about. There's also what's called OpenAuth and OpenID connects. You've used this if you've ever been to a website that's like, hey, if you want to log on in, click here to log on with Facebook or Twitter or something like that, or Gmail or Apple ID. So instead of you having to re-authenticate to a website, they're like, just click here to use your Gmail account or Facebook account or Twitter account or Apple ID account. All you got to do is click this button, right? Just log in with Facebook, log in with Google, log in with Apple. Whenever you're doing that, you're using a protocol called OpenAuth and OpenID Connect. But attackers can actually send you URLs that, if you look here, it's anytime I see a URL with OAuth in it, you'll see that in that first line there. This really is going to take you to the real Microsoft Online and OAuth. But then you'll see that redirect URI, Uniform Resource Indicator. That's where it's taking you to a different website. And then it's saying, when we go to this real website, give that other website the ability to read and write all your files. So again, anytime I see this OpenAuth, if I'm going to be redirected to some other website, I want to see where that website is. And I never want to click yes if it's asking to read and write all my files. Although you'll get prompted, hey, are you sure you want to allow this new website to read and write all your files? Yes or no? But it's going to default, unfortunately, to allow. So if you're not paying attention or you hit enter or something like that, you've just given the ability to read and write all your files to that particular fake website. So be careful of that. And Dropbox and stuff uses this OpenAuth. It's used legitimately all over the place. I don't have time to show you where to go into, but just know that you can actually review your OpenAuth permissions. And in the slide deck, I tell you where to go to find out what websites have your permissions, OpenAuth permissions. So I tell you how to go into Gmail and take a look to see who you've assigned permissions, and then remove people you don't need. But in general, just look out for these secondary redirects. So if you see this, a second URL or a redirect or something like that, be careful about clicking on that. The way that you can fight all of these is that they will, again, you'll end up being redirected to the new web page. We're running out of time here. I had some other slides that just talk about how you can safely examine different URLs, but I want to take some questions here. I apologize. Download this web deck. And then you can see how to safely examine those URLs in a forensic browser session or something. But if we don't get to your questions today, we're running out of time. You can email me at rogerg@noble4.com, and I promise to answer all your questions. And you can follow me on LinkedIn and Twitter. But Dave, I know we only have a couple of minutes left, but I'd love to take some questions.
Absolutely. Yeah. Fantastic presentation. As always, Roger, we have a ton of questions here rolling in. The question here is where to start. Let's see. First question, I want to ask you, these folks here, they use KnowBe4 already for phishing tests and training, but they have some end users who continually fail the phishing tests. Any advice for them?
I say, one of the things to do is teach them how to read how to read the difference between a legitimate and a rogue URL. That's one of the best skills, and there's even, download that red flags of rogue URLs. It has the 12 most common tricks that hackers and phishers try to use to trick you into clicking on the wrong link. If you teach your end users how to better inspect URLs, they're going to be phished less often, for sure.
Absolutely. Yeah, I take my training every month from KnowBe4, and I enjoy it and learn a lot. So I highly recommend it. Another question here. Is there anything else that can be done to programmatically block these kind of links? Let's see, Michael's asking about like a GPO policy or web browser configurations.
Yeah, I mean, you can try it, but they ultimately fail. They do. I don't care what defenses you use. There's going to be some amount of badness that gets by to your end users. But if you can teach them how to spot the difference between a legitimate and rogue URL, it's going to beat any other defense that you can come up with.
Got it. Another question here they're asking, is there a certain web browser that might help to prevent these kinds of attacks?
No, I mean, all the web browsers are getting better all the time, but again, they all fail. They all allow bad stuff through. I do like the idea that a lot of times they highlight the real domain name and make it bolded, but sometimes the bolding is not as sharp as it should be. But most of the browsers have that ability today. I mean, certainly Google and Safari and Chrome and Edge and that sort of stuff. And I think Opera. But I would say look for a browser that highlights the real domain name. That right there will give you if you're looking, will help you out.
Got it. Okay. This is an interesting question. Can trust be faked in a URL? So if you get the little green lock in your web browser, does that mean you're secure, or could that URL still be, maybe trusted, but going to a fake website?
Yeah, I talked about that. Most websites, I think it's 90% of rogue URLs have trusted digital certificates. So you just really can't trust them today.
Wow, that's incredible. Are there any tools out there that can help users check the URL before they go to a website?
There's not a lot of them. Again, I've given you the skills to try to check it yourself. You can, though, post it. If you go, most antivirus vendors have kind of URL checking links, but they're not super accurate, but it's something to try. One that I like to use a lot that's free. It's owned by Google, but it's called virustotal.com, www.virustotal.com. They have an area where you can submit links to see whether or not they have malware associated with them. But overall, they're not super accurate. But if you learn how to read URLs, you can be super accurate.
Awesome. Let's see. Paul is asking, really, what's the greatest threat from going to a rogue URL? So someone goes to that rogue URL. What's the bad thing that typically happens after that? Is it phishing? Is it social engineering?
Yep. Yeah, 50% of the time they're just trying to trick you into giving them your login credentials. A lot of times, though, they're trying to get you to download a Trojan horse program. That's really, really common, that takes over your machine and then takes over your network, and you got ransomware. And then sometimes they can even steal your password. So, clicking on links is a bad thing. You don't want to do it if you can avoid it.
Absolutely. And then let's see. what does it take for a silent drive-by download to occur?
Yes, yeah. So that's when you go to like a website and you get exploited or infected without doing anything. Like you think you're just doing fine, but behind the scenes you've been infected. Almost always requires that you have unpatched software. If you perfectly patch your software, silent drive-by downloads usually will not impact you.
Got it. Okay. And then what about would SPF, DKIM, and DMARC catch these rogue URLs?
Usually not, and that's because that kind of like TLS digital certificates. Most attackers are now registering their rogue URLs with DKIM, SPF, and DMARC. So they do help. They do cut down. DMARC, SPF, and DKIM do help get rid of that. That stops somebody from faking from being from somebody else's domain. So if somebody claims they're from KnowBe4 and they're not really from KnowBe4, it stops that sort of attack. But they can register those like dash paypal.com and register their domain with DMARC, and then it's going to come across as not having violated DMARC. Something like 80-90% of rogue URLs are now registered with SPF, DKIM, and DMARC, so it's not as helpful as it used to be.
Wow. Wow. The bad guys are getting smarter and smarter every day. Roger, I'm afraid we've run out of time here in our webinar time slot. But again, fantastic presentation. Thank you so much for being on.
Thank you. And thanks everybody for showing up.
Absolutely. Thank you to the audience out there for joining us on the event today. Roger has graciously provided his email address there on the screen. If you have a question we didn't get to answer it here on the live event, or if you have follow-up questions after, don't forget about the handouts tab there. It's there. You can download the free phishing or go perform the free phishing security test and then download the red flags of rogue URLs. Thank you, of course, to KnowBe4 for supporting the event today. And I do want to now announce the winner of our Amazon $300 gift card. This is going to Aaron Rousler from South Dakota. Congratulations. We'll also reach out to our best question prize winner, which is going to be a tough decision to make there. For more information, go to visit knowbe4.com. Thank you, everyone. I hope you enjoyed the event and have a great day. See you next time. Bye-bye.